Hello and welcome back to another IB Math speedrun with me, Vince. This is the second and final speedrun of chapter 6.1, so let's jump right in. So the next thing and final thing we have to cover is the surface area of 3D shapes. Yeah, volume and surface area of 3D shapes. So the first thing we need to realize is that surface area is equal to the derivative of volume with respect to radius, just like circumference is the derivative of area with respect to radius. And we can express this by, say, the volume of a sphere. Well, we know this is 4/3 pi r cubed. And if we get the derivative of this, we simply get 4 pi r squared, which is the surface area indeed. So this is an important thing to know. Other than that, you need to memorize the usual volume and surface area calculations for most normal 3D shapes. So volume of a pyramid is equal to 1/3. Oh, I can't type. Pyramid is equal to 1/3 base times height. And by extrapolation, or not, actually it's interpolation, the cone is equal to 1/3 times pi r squared h, since pi r squared is the area of the base. We need to know that surface area of a sphere is 4 pi squared r. The surface area of a cone is pi r squared plus pi rs. That's the cone, and the volume of a sphere is 4/3 pi r cubed. So you just need to know those simple things, and yeah, that's enough for us to already jump into some questions. So let's go. And so I am going to be doing it's not even ones. It's the every other one, starting with the second question this time. So not sticky notes. So the second one is find the volume and surface area of each shape. And this first shape is a nice pyramid. We have 4 centimeters, 5 centimeters, and the height, perpendicular height, is 6 centimeters. So volume is 1/3 pi. Sorry, not 1/3 pi. 1/3 base times height. Base in this case is 20. Height is 6. Excuse me. So that's equal to 20 times 2, or 40 centimeters cubed. Now, what's the surface area like? Okay, so this gets a bit tricky. So the thing is, the surface area in this case, well, we might have to manually calculate it by using some Pythag. So if we look at the shape in depth, then we can see we can actually split it into some rectangles, but we need to know this line and this line, the lengths of these two lines. So first, the base is clearly 20 centimeters. And then on this side, we have a rectangle with a width of 2 and a height of, this is 2.5, so we have 2.5 squared plus 6 squared, square root of that. So we have this as 6.5, and we have 6.5 times, well, 2 times 2 for the other side, so 6.5 times 4. So we have 26 for that triangle. For this triangle here, we have 4 plus 36, square root 40, and then we have square root 40 times 2.5 times 2. So we have plus 31.6, almost that. So that plus 26 plus 20, we should end up with a surface area of around, okay, so the book has made an error. I don't know how, but the correct answer is 77.6 or somewhere around that. The book, I don't know how it's off. This book actually has too many errors. Anyways, on to the next one. We have the cone, which of course has a volume of 1/3 pi r squared h. We have a radius of 1 and a height of 3. So we have 1/3 times pi times 1 squared is 1 times 3. So we have an area of pi. Now, surface area of a cone is pi r h plus pi r s. Sorry, I mean well, wait. Yeah, so it's surface area of a cone is pi r squared plus pi rs, but s is the slight, so this is root 10. So we have pi r squared, which is pi, plus pi rs, which is root 10 pi. So our total surface area is pi plus root 10 pi, and our total volume is pi for this one. So yeah, 3.14 and around, I think, 13.1. Okay, on to the last one, and that one is a sphere with radius 6. Well, okay, volume is 4/3 pi r cubed. So that's equal to 4/3 times 27 times pi, so it's around 4/3 times 27, so this should be around 36 pi, and surface area is 4 pi r squared, which is 4 times 6 squared, so it's around 144 pi as a surface area, and 4/3, actually, wait, no. This should be around 100, this should be 144 as well, actually. This would be 4 times 6 squared times 2. Oh, 288 pi. Oops. Yeah. So 288 pi and 144 pi. So let's just check that. I don't understand. The book is wrong again. I'm just confused. Unless they've mixed up. No, they haven't mixed it up. The book is wrong again. So you should get 288 pi as the volume and 144 pi as the surface area. Okay, on to the next problem. And so the next problem is we have a cone like this. A cylinder and a cone. Looks like a rocket. And so this is 9.1. This is 6.2. And this radius here is 3.2. So we need to find the volume of the solid. Okay, this is pretty simple. This is pi times 3.2 squared times h, which is 9.1, plus 1/3 3.2 squared, 1/3 pi times 3.2 squared times 6.2. So this is equal to, let's simplify this, 9.1 plus 1/3 plus 6.2 over 3. And this all times 3.2 squared. So we should get something like 114.3 pi. That's what I got as the answer. So let's multiply this by pi to get 359. Yeah, that's correct. Okay, and on to the final question. And that one is, we have 12 spheres, each with a radius of 3 centimeters, are fully immersed in a cylinder of water with radius 10 centimeters. Find the rise in the water level. Okay, so if we have 12 spheres, each with a radius of 3 centimeters, that means the total volume is 4/3 pi r cubed, which is equal to 36 pi, since 4 times 9. And so the 36 pi, and for every unit of height, well, the cylinder will take up a volume of 10, to radius 10, so pi r squared. So it's 100 pi per cm in height. So we have 36 times 12 divided by 100, which is equal to, I think, 4.32 centimeters. So yeah, I think we should see a rise of 4.32. Oh, nope, is it not that? Okay. 4/3 pi r cubed, radius 3 centimeters, so that is 4 times 9, 36 pi. 36 pi per sphere times 12 spheres. So 36 times 12 is 432 pi. Now, the water level is a cylinder of water with radius 10. So if it's radius 10, then for every unit of height, where height is equal to 1 centimeter, it rises 100 pi. And so we should just have 432 pi over 100 pi, which is 4.32. But the book is giving something that's different, so I don't know. I think I'm right on this one, honestly. And so yeah, that's the end of the speedrun. I hope you enjoyed, and I hope to see you in the next one. See you then.